Okay, so very welcome also from my side. I'm Bernd Schiele, also from the ELLIS Units in Zurich, actually. I'm very happy to present the award, the PhD Awards 2020 on behalf of ELLIS. Since, as you heard multiple times, supporting and attracting talent is at the core of the ELLIS mission, it's a very suitable, right, to present also the ELLIS Award, the PhD Award here during this event today. Just to give a bit of background here, the goal is to recognize and encourage outstanding research achievements during the dissertation phase in AI, machine learning, and related fields like computer vision and robotics. The setting is that we will be giving every year, typically 2 awards, one female, male candidate, typically per calendar year. Last year, we started this, this process by was given for the first time, and we actually gave for the 3 previous calendar years, 16, 17, and 18. So we gave 6 awards back then. This year and for the following years, what we will do is that we'll give typically 2 awards per previous calendar year. So today we're giving awards for the year 2019. And the eligibility is pretty simple, right? If the PhD has been done or performed at a European institution for the most part, right? Obviously people, if they move for a bit outside, that's not a problem, right? But really for the most part, they should be basically be in Europe, and it has to be being defended in the previous calendar year. Yes, so it actually is sponsored, and it's a great pleasure to me to say a few words about the Kubert Foundation, the Stiftung GmbH. They give the prize money, €2,500 for each of the candidates. And actually, the foundation was established several decades ago, right? And already it was established right by Wolfgang and Helga Kubert to promote research and teaching in the natural, technical, and economic sciences. And actually, in 2018, they reached out actually to us. The foundation reached out basically because they wanted to support AI, advances in AI, to promote academic excellence, as well as to propagate the European idea. And that is really a perfect fitting for the ELLIS network. And it's really so very glad that they have committed to sponsor this, this PhD award for a number of years to come. Right, so it's a very lightweight process. So anyone who is interested to think about this nominating or being nominated, go to this webpage, right? It's a really lightweight process, a short summary, a few publications, your PhD, CV, and short citation. It's really not a big deal really to get this documents together. We will have another opening next year, right? Again, around April or so will be again the next nomination deadline. We had again also a very lightweight sort of committee. This year's was pretty small, also because of COVID. We had a few declines because people couldn't, spend time on this during these times. I happened to chair this. We had Antonio, Bernhard, Max, and Yaria basically looking at the nominations and then basically selecting the award winners. Right. So and that brings me already to the winners, right, of this year's PhD Awards 2020. And as I said, there will be 2. The first one is Felix Berkenkamp from ETH Zurich. Let me just briefly read to you the laudation by Andreas Krause, his PhD supervisor. Felix's dissertation breaks new grounds by pioneering provably safe reinforcement learning algorithms and demonstrating them on robotic platforms. His approaches use probabilistic models for cautiously learning about the system online, while eventually enabling increasingly performant behavior as supported by data. The dissertation elegantly integrates ideas from machine learning and control theory. And sort of once I'm done, basically also Felix will give a 2-minute pitch about giving a short introduction about his PhD. The second winner is Gül Barol, who did her PhD at INRIA and ENS in Paris, in France. And again, let me read the laudation by Cordelia. The thesis of Gül is of excellent quality, covering a wide range of challenging and important problems in human analysis. The significant contributions are reflected in a series of top-tier publications. The scientific outcomes of the thesis have had high impact in the computer vision community and have been followed up and extended by numerous groups. This has been supported by open sourcing. So normally now comes sort of the moment where we hand over the certificates, right? So here they are. They had been signed already in July. I think we have to do something here to basically, switch on your microphone and clap for Felix and Gül, and please sort of congratulate them here at this point to the awards. I know it's a little sort of, how to say, devastating that this is not sort of a more, exciting event, I suppose, but, we will at least sort of, we will send you this certificates right after today, basically, including also the money. And hopefully we will have the opportunity to also congratulate you more in person soon. So now we'll have first Felix giving a short sort of overview of his thesis, just 2 minutes, but to give you an idea. So Felix, it's your turn.
All right, so first up, thanks a lot for this award. I'm extremely honored to receive it. And I would also like to take this opportunity actually to thank my advisors, so Andreas Krause and Angela Schollig, as well as all the fantastic collaborators that I had the opportunity to work with. So thank you. So this thesis is motivated by autonomous systems that leave kind of the safe settings in factories and in labs and go out into the real world where they face large prior uncertainties and where they also have to act safely in order not to break the system or harm the environment. So at the same time, we want these systems to achieve high performance, which means they need to learn and adapt to their environment in a safe way. So if you look at the next slide, you can consider like a quadrilateral system where we have, as an example, where we have a policy, and depending on which parameters we pick for the policy, the quadrilateral will fly different trajectories, for example, the blue or the red trajectory. The goal here is to find the best parameters that achieve the highest performance as encoded by a reward function. But at the same time, we want to guarantee safety during the entire learning process. In this case, this could, for example, mean not crashing into the obstacles at the side of the corridor next to the quadrilateral. So the thesis kind of builds up a theoretical foundation for this problem and uses statistical models to quantify uncertainty during the entire learning process. And then the algorithms cautiously explore relative to that uncertainty in order to optimize the system safely. And this kind of relative to the standard reinforcement learning problem where we have the exploration and exploitation problem, this is an extended problem where additionally we have to consider our actions, how they affect the safety. On the next slide, I actually want to show you one specific instance of the thesis. So this is the video of a quadrilateral. It has the goal to go from left to right as quickly as possible with minimum tracking error. So we want it to go as quickly as possible and then also not wobble around the target. In the bottom right, you can see a statistical model that's learning a mapping from the controller parameters to the resulting performance and safety of the controller and the robotic system. Now, the algorithm proceeds by considering the uncertainty in the statistical model and selecting parameters that are both safe relative to the estimated uncertainty and that allow us to, at the same time, learn about the best performing parameters. And by handling this trade-off in an efficient way, we can ensure that we both safely and efficiently learn about the optimal parameters. And you can see kind of a quick video here of a comparison of the initial parameters and the safely learned optimized parameters. So in summary, this thesis kind of builds up a theoretical foundation for safe exploration in both model-free and model-based reinforcement learning, with the hope that this will in the future enable autonomous systems to safely learn about their environments.
Okay, thank you very much, Felix. That brings me to the second recipient, Gül Varol. So it's your floor to say a bit about your work, please.
Thank you, Bernd, and hello, everyone. I also like to first thank the selection committee for this award and say that I'm really honored. Then I thank Ivan Leptev, Cornelia Schmidt, Michael Black, and all collaborators for their support. So just to give you a brief overview of the thesis, I'm showing some of the highlights of the PhD works. And the common theme here is human analysis from visual data. And we focus on two particular aspects of this. One is human body analysis from images. One is human action recognition from videos. For human bodies, we've introduced the surreal data set, which is an effort to synthesize humans so that we have training data to learn tasks such as segmentation with convolutional neural networks that are data hungry. And we've also used the data and others to estimate 3D human body shape. And we've introduced this BodyNet multitask architecture that obtains state-of-the-art by using volumetric representation for human bodies. Then we've extended our works on synthetic data to hand object reconstruction. This time we've synthesized grasps. And we've also introduced some contact loss between the hand and the object to favor physically plausible interactions between them. For actions, we've also started by addressing the data problem because the data sets for action recognition until then were mostly collected from YouTube or movies, which have the bias of being fun and interesting. For instance, when you query on YouTube opening a fridge, you get dogs opening fridges, whereas it's very difficult to get ordinary scenes. So with this motivation, we have introduced a crowdsourcing pipeline where an annotator writes a script and another annotator acts it out and films it, and we get these videos with annotations. So this resulting charades dataset has been standard since then for action recognition for various tasks. And lastly, in terms of the architecture, how to handle video inputs was unclear with neural networks, and people have tried stacking 2D video frames with 2D CNNs, or recurrent neural networks and time, or 3D space-time convolutions. But none of these attempts really obtained improvements over handcrafted features. And we've done an analysis and found out that, well, it could be obvious now, but found out back then that one needs to have long temporal extent to obtain high performance from space-time convolutional neural networks. And this has become standard also nowadays. Thank you for your attention, and the thesis is available online.
Yes, this brings me to the end. Thanks very much again for all the great PhD work that was submitted and we had the pleasure to evaluate. Thanks very much for the Kubert Foundation to help us finance this, this award. And for the next round, right, look at the webpage. There will be again an opening, will be again a nomination period for the next year, 2021. We're looking forward to your submissions. Thank you very much.